Today, our topic is to learn about algebraic expressions. This is the first chapter of Algebraic Pure Mathematics 1 textbook. Initially, we need to understand the index form of a number. For example, if you get x to the power 5, we know that 5 is the base, x is the base, and 5 is the power or index, or we call exponent. The first law of index law is if you multiply two terms with same base, you can write the final answer with the addition of two powers. A to the power m into a to the power n, you can write a to the power m plus n. Similarly, if you divide two terms with same base here, you have to understand that to operate these theories, the base should be the same. Therefore, if you divide any terms with same base, you can write the final answer with difference between the bases. For example, if you get a to the power m divided by a to the power n, your answer would be a to the power m minus n. The third rule is a to the power m times of b to the power n. This is called power of power theory. Then in that situation, you can write the final answer as a to the power m into n. This is the theory we are going to understand. The other one is, this is some kind of exceptional theory. If you get two terms multiply and if you write as a power n, you can write this term as a to the power n into b to the power n. Those are the basic principles we have to understand under index law. Apart from that, there is another theory, that is if you get any term to the power 0, we know that this power is equal to how much? 1. That's the other exceptional theory where we have to understand. Apart from that, you can write some power to the power negative n or something with a negative power. If you get a negative power, you can write this answer as 1 over a to the power n. You can brought it to the reciprocal of it and you can write it as the positive power. The other side is if you get 1 over a to the power minus m or something, therefore you can take the reciprocal of it. Reciprocal means the upside down and you can write this answer as a to the power m. These are the other exceptional theories where we have to understand under this topic. And this one. So you can note down these facts and you make your own note with this. Right. If you go ahead with the next part of it. Right. Let's come up with this example. If you have to multiply x to the power 2 into x to the power 5. From this theory, if there's a multiplication, you can add the power. So you can write this is x to the power 2 plus 5, that is x to the power 7. Right. The next extension is if you want to multiply 2r to the power 2 times of 3r to the power 3. Initially, you can multiply these digits 2 into 3 into you can this multiplication, these are the algebraic multiplication, you can add these two powers. Then you can write the final answer 2 into 3 is 6, r to the power 2 plus 3 is r to the power 5. This is your final answer, right? Okay. If you come across a question like this, b to the power 7 divided by b to the power 4. If there is a division from this theory, we know that you have to subtract the powers. With that, you can say this is b to the power 7 minus 4, that is b to the power 3, right? If you go ahead to the next extension, that is 6x to the power 5 divided by 3x to the power 3. If you have such situation, you can divide the numbers separately and the algebraic term separately. 6 divided by 3 is 2. This division, you can write it as a subtraction. So this will turn up into x to the power 5 minus 3. Division, you can write it as a subtraction. With that, you can say this is x to the power 2. The final answer is 2x to the power 2. Right. Then, the other fact is if you have a question like this, a to the power 3 to the power 2. This is the power of power theory. From this theory, you can apply this term as 3 into 2 is a to the power 6. Straightforward, you can write this is a to the power 6 into 2 times of a to the power 2. Right. Initially, I just apply power of power theory and I have obtained the answer a to the power 6. Then you can multiply. Then 2, there is nothing to multiply with 2. Then this multiplication you can write it as addition. A to the power 6 plus 2 turn up to a to the power 8. This is the final answer for this question. Right. Let's go ahead with this question. 3x to the power 2 to the power 3 divided by x to the power 4. If you have a power like this, using this theory, this power comes to both of these expressions. So this is turned up to 3 to the power 3 and x squared to the power 3. 3 to the power 3 is 27. X squared to the power 3, again you can apply power of power theory and you can write x to the power 2 into 3. That is x to the power 6 divided by 4. Then we know that this division you can apply x to the power 6 divided by x to the power 4. That is division theory, means over here if there is a division you have to subtract the powers. So you can write this answer as x to the power 6 minus 4, that is 2, that is 27. X to the power 2 would be the final answer for this question. So all the operations are mentioned over here. Right. The next example is we need to expand these expressions and simplify if possible. What you need to do is, if you want to simplify, we know how to remove the brackets. Then let's come up with this. 3x into minus 3x into 7x. Minus 3 into 7 is minus 21. X into x is x squared. Then you can multiply minus 3x with minus 4. Minus 3x multiplied with minus 4 is plus 12x. So this is your final answer, right? The next example is y squared times of 3 minus 2y cubed. Then first this bracket. If you expand, y squared into 3 is 3y squared. Y squared into minus 2y cubed is minus 2. There is no what you call numeric multiplication, just minus 2. Y to the power t into y to the power 3. Y to the power 2 into y to the power 3 is, if you add the powers, that is turned up to y to the power 2 plus 3. That is y to the power 5. Okay, right. Then the next extension is 2x times of 5x plus 3 minus 5 times of 2x plus 3, right? Then 2x into 5x is 10x squared. 2x into plus 3 is 6x. Minus 5 into 2x is minus 10x. Minus 5 into plus 3 is minus 15. So you cannot add x squared terms with x term, but you can add the similar x terms, 6x and minus 10x. 10x squared, 6x minus 10x is minus 4x, minus 15 is your final answer. Right. The next theory is simplify these expressions. Right. The question is x to the power 7 plus x to the power 4 divided by x to the power 3. If these terms are separated by additions or subtraction, and if the denominator is just a single term, you can divide these terms individually. Then you can straightforward write x to the power 7 divided by x to the power 3 plus this operation comes over here, x to the power 4 divided by x to the power 3. Then here this division you can write it as a power subtraction of powers, x to the power 7 minus 3 plus x to the power 4 minus 3, that is x to the power 1 is x. So your final answer is x to the power 4 plus x, right? The next extension is 3x squared minus 6x to the power 5 divided by 2x. Same theory we can apply. 3x squared divided by 2x minus 6x to the power 5 divided by 2x. Then 3 over 2 x to the power 2 minus 1. This division you can write it as a subtraction of powers. 6 divided by 2 is minus 3. Minus 6 divided by 2 is minus 3. X to the power 5 divided by x is x to the power 5 minus 1. So this answer turn up into 3 over 2x to the power 1. 2 minus 1 is 1. It's over here. Minus 3 x to the power 5 minus 1 is x to the power 4. With that you can obtain this answer. Right. If you reach back to part C, Here also you can use the same operation. 20x to the power 7 divided by 5x squared, 15x cubed divided by 5x squared. So operation in between is addition, right? Then 20 divided by 5 is 4. X to the power 7 divided by x to the power 2, you can write x to the power 7 minus 2, the subtraction rule. Then 15 divided by 5 is 3. X to the power 3 divided by x to the power 2 is x to the power 3 minus 2. So your final answer is 4x to the power 5 plus 3x to the power 1. You can write power 1 as just 3x, right? Let's come up with this. The question in the exercise 1A, right? Okay. The first question, this is pretty simple. If you want to multiply, you have to add the powers. X to the power 3 into x to the power 4 is x to the power 3 plus 4 is x to the power 7, right? If you come up with the second question, 2x to the power 3 times of 3x to the power 2. Initially, you can multiply these two numbers. 2 into 3, that is 6. Right. Then when you multiply, what happened? The power should be added. X to the power 3 plus 2 is x to the power 5. Answer is 6x to the power 5. Right. If you come up with the next example, that is k to the power 3 divided by k to the power 2. So simply division means subtraction of powers. K to the power 3 minus 2 is k to the power 1. That is just k. Right. Then 4p to the power 3 divided by 2p. So simply you can divide these two terms. 4 divided by 2 is 2. This what you call algebraic division, you can subtract the powers. P to the power 3 minus 1. This division you can write it as a subtraction of power. That is p to the power 2. So your final answer turn up to 2p to the power 2. Right. The next extension is 3x to the power 3 divided by 3x to the power 2. Then you can say 3 divided by 3, that is 1. X to the power 3 divided by x to the power 2 is x to the power 3 minus 2. That is the term. So x to the power 3 minus 2 is x to the power 1. X to the power 1 is just x. So 1 into x is x. So you can obtain the final answer as x. That's what you need to understand from this question, right? Then this is power of power theory. If you had such operation, you can multiply these two powers. Y to the power 2 into 5, that is y to the power 2 into 5, y to the power 10. So simply you can obtain the answer y to the power 10, right? Then this question, 10x to the power 5 divided by 2x to the power 3. So initially you can divide these two powers. 10 divided by 2 is 5. X to the power 5 divided by x to the power 3 is you can subtract the powers. That is x to the power 5 minus 3, that is x to the power 2. Our final answer is 5x to the power 2, right? The next operation is, it's a combination of power theory and a division, right, over here. So initially, if you work out over here, what you can get, you can multiply these two powers. This is called power of power theory. That is 3 into 2 is p to the power 6 divided by p to the power 4. Division means you can subtract the powers, that is p to the power 6 minus 4, that is p to the power 2, right? Then this is another extension of that question. If you had this kind of a power, you have to put this power for both of these expressions. That is 2 to the power 2 into a to the power 3 times of 2. So you can multiply the powers 3 to a to the power 6. So you can say 2 to the power 2 times of a to the power 3 to the power 2. 3 to the power 2 is a to the power 6. Divide by 2a to the power 3. 2 to the power 2 is 4. A to the power 6 over here. Divide by 2a to the power 3. Then you can operate 4 divided by 2. 4 divided by 2 is 2. A to the power 6 divided by a to the power 3, you can write a to the power 6 minus 3, the division of the powers. With that, you can say final answer is 2a to the power 3. That's the final answer where you have to obtain over here, right? Now let's come up with question number J, right? Okay. Then 8 xp to the power 4 divided by 4p to the power 3. Then you can divide these two numbers separately. 8 divided by 4 is 2. Right. P to the power 4 divided by p to the power 3 is you can subtract the powers and you can obtain the answer as p to the power 1. So your final answer is 2p. Right. The next question is 2a to the power 4 divided by 3a to the power 5. then initially you can multiply these two terms. 2 into 3 is 6. Then a to the power 4 into a to the power 5 is a to the power 4 plus 5, that is a to the power 9. So your final answer is 6 a to the power 9. Right. Then if you come across this question, 21a cube b7 divided by 7ab to the power 4. Initially you can operate 21 divided by 7 separately. Then a terms, a to the power 3 divided by a into b to the power 7 divided by b to the power 4. 21 divided by 7 is 3. This operation you can subtract the powers a to the power 3 minus 1 into b to the power 7 minus 4. Therefore, 3, a to the power 3 minus 1 is 2, b to the power 7 minus 4 is b to the power 3. That is the answer for question number I. If you come up with question number part M, in this question part M, 9x squared into 3 times of x to the power 2 to the power 3. So simply you can operate this to 9 into 3. X to the power 2, here this is power of power theory. X to the power 2 into 3, that is x to the power 6. Then x to the power 6 multiply with x to the power 2, you can add the powers. Then your final answer turn up into 27 x to the power 8. That is the answer for part M. Right. If you come across part N, 3x cube into 2x squared plus 4x 6. So you can just multiply 3 into 2 into 4. This is x to the power 3 into x to the power 2 into x to the power 6. You can add these powers. X to the power 3 plus 2 plus 6. That is x to the power 11. 3 into 2 into 4 is 24. That is how you can obtain this answer. Right. The next theory is 7a to the power 4 into 3a to the power 4 to the power 2. So this one you can simply write, and here you have to put this power 2 to both expressions. 3 to the power 2 is how much? 9. A to the power 4 to the power 2, that is power of power, that is a to the power 4 into 2 is 8. Then you can multiply 7 into 9 is 63. A to the power 4 into a to the power 8, you can add the powers and you can write a to the power 12. That is how you can obtain that answer. If you come up with the next part of this question, 4y to the power 3 to the power 3 divided by 2y to the power 3. Here also you have to put 4 to the power 3, y to the power 3 to the power 3. 4 to the power 3 is 64, 4 into 4 into 4. Y to the power 3 to the power 3 is, you can apply the power of power theory and you can write 3 into 3, y to the power 9 divided by 2y to the power 3. Then you can divide these terms. 64 divided by 2 is 32. Y to the power 9 divided by y to the power 3. So you can subtract the powers and you can write y to the power 6. Right. All of these questions are, you have to use the same theory and see whether can you understand how to do these questions, right? Then next we will come up with the expansion of the brackets. This is not a much hard question, but let's go ahead with few questions and see whether can you understand how to do these kind of questions, right? Then if you come up with this is pretty simple. You can multiply 9 with x and 9 with minus 2. 9 with x is 9x, 9 with minus 2 is minus 8. So your final answer turn up into 9x minus 18. We have already practiced this in our IGCSE classes as well. Then x into x plus 9. So what we need to do is x into x is x squared. X into 9 is 9x plus 9x. So you can obtain the answer over here. Then if you operate this, minus 3y into 4 is minus 12y. Minus 3y into minus 3y is minus minus plus 3 into 3, 9. Y into y is y squared. So your final answer become minus 12y plus 9y squared, right? If you come across this question, this is x into y is xy, x into 5 is 5x. Therefore, your final answer is xy plus 5x. If you operate this answer, minus x into 3x is minus 3x squared, minus x into 5 is minus 5x. Here, you can say minus x into minus 3x is just minus 3x squared, minus x into plus 5 is minus 5x. So your final answer is minus 3x squared minus 5x, right? If you come across with the fifth question, part F, minus 5x into 4x, minus 5 into 4 is minus 20, x into x is x squared. Minus 5x into 1 is minus 5x. So your final answer is minus 20x squared minus 5x, right? Then you can work out this expression. Then you can multiply like this. X into 4x is 4x squared. X into 5 is 5x. With that, you can obtain this answer, right? Then if you come up with part H, right? Minus 3y into 5 is minus 15y. Minus 3y to minus 2y squared is minus 3 into minus 2 is plus 6. Y into y squared is y cubed. So your final answer is minus 15y plus 6y cubed, right? The next expression, minus 2x into 5 is minus 2 into 5 is minus 10. X into x is x squared, minus 10x squared. Minus 2x into minus 4 is minus 2 into minus 4 is plus 8x. So your final answer is minus 10x squared plus 8x, right? Then if you come up with a question number J, right? So you can work out the single term to the multiple term. X squared into 3x is 3x cubed. 3x into x squared is x cubed. Minus 5 into x squared is minus 5x. But this is our final answer, right? If you come up with this example, here 3 into x is 3x, 3 into 2 is 6. Then there plus there is no operation over here. You can just write x minus 7. It just multiply here with 1. Right. So 3x plus x is 4x, 6 minus 7 is minus 1. Like that, you can get the answer. Right. Okay. Here also 5x minus 6, there is no multiplication. Then multiply this bracket. This is kind of important. But to multiply this entire bracket, both the terms with minus. Minus into 3x. This is just like minus 1. Minus 1 into 3x is minus 3x. Minus 1 into minus 2 is plus 2. Then you can operate 5x minus 3x is 2x. Minus 6 plus 2 is minus 4. Right? Okay. Then if you come across with this operation, right? Let's see how to do that kind of a question, right? Okay. Then this is 4 into c is 4c. 4 into 3d squared is 12d squared. Minus 3 into 2c is minus 6. You have to remember that when you multiply, you have to multiply entire all the terms inside the bracket with the term outside with the sign. Minus 3 to d squared is minus 3d squared. With that, you can operate 4c minus 6c is minus 2c. 12d squared minus 3d squared is 9d squared. Like that, you can operate these brackets, right? The next expression is this. Here, there is nothing to multiply. Over here is 1. Therefore, you can just write r squared plus 3d squared plus 9. And this bracket has to be multiplied with minus. Minus into 2r squared is minus 2r squared. Minus into 3d squared is minus 3d squared. Minus into minus 4 is plus 4. Right. Then you can operate r squared with minus 2r squared. Then that answer is minus r squared. 3d squared minus 3d squared, both two terms get cancelled. That is 0t squared, that is get cancels. 9 plus 4 is turned up to 30, right? Like that, you can operate entire stuff in this brackets. So if I just review with this part B, 3x squared into 2x is 3 into 2 is 6, x squared into x is x cubed. 3x squared into 1 is 3x squared, minus 5x squared into 3x. Minus 5 into 3 is minus 15, x squared into x is x cubed. Minus 5x squared into minus 4 is minus 5 into minus 4 is plus 20 x squared. With that, you can operate these x cubed terms. Here, 6x cubed minus 15x cubed is minus 9x cubed. 3x squared plus 20x squared is 23x squared. So your final answer turn up to 23x squared minus 9x cubed. Right. Then the other part is just expanding bracket, the same expressions where we have done. So when you are expanding x plus 5 into x plus 2, you can multiply x into x is x squared. X into 2 is 2x. 5 into x is 5x and 5 into 2 is 10. Then you can see the similar terms are 2x and 5x, that is turn up to 7x. You can write the final answer as x squared plus 7x plus 10. Right. Then if you come up with a question number B, let's see how to do this expansion. Right. Then you can work out x into x squared is x cubed. X into 1 is x. Minus 2y into x squared is minus 2x squared y. 2x squared y. Then this term into this. Minus 2y into 1 is minus 2y. Now you can see there are no similar terms. Right? All the terms have been different. This is x cubed. This is just x squared y and y. So there is no further simplification. You can keep the answer as this, right? The next one is x minus y squared. So some students make this mistake. They just take x squared minus y squared. That is wrong. You have to understand this is a common mistake where most of the students do. The x minus y squared means x minus y into x minus y. Let's try to do this expansion. X into x is x squared. X into minus y is minus xy. Minus y into x is minus xy. So if you write xy or yx, the same thing. I will tell you what is the reason I am used to write y. Both the terms write it as xy at the end of this question. Minus y into minus y is, here also some students make the mistake. They forget this minus minus plus and they just write minus y squared. But the final answer is minus minus plus y squared. Then you can simplify minus xy minus xy. That is minus 1xy minus 1xy. Minus 1 is minus 2. Answer is x squared minus 2xy plus y squared, right? Then if you work out the questions over here, so you can say, you can multiply the entire brackets with x. X into 3x, 3x squared. X into minus 2y is minus 2xy. X into minus 4 is minus 4x. Then y. Y into 3x is 3xy. Y into minus 2y is minus 2y squared. Y into minus 4 is minus 4y. Now I'll check whether are there any similar terms. X squared terms, only this. So you can write just x squared. Xy terms, there are two xy terms. Minus 2xy plus 3xy is plus 1xy. That is just xy. X terms, this is the only y squared term, that's all. Y terms, this is also your final answer is 3x squared plus xy plus minus 4x minus 2y squared and minus 4y, right? If you come up with this kind of expansion, what you can do here is, initially I can multiply this 2x plus 3 with x. 2x into x is 2x squared, 2x into 3 is 3x. Then multiply this expression with x minus 7, right? What you can do is, 2x squared into x is 2x cubed. 2x squared into minus 7 is minus 14x squared. 3x into x is 3x squared. 3x into minus 7 is minus 21x. Now see whether the similar terms. X cubed terms, only this. So you can just write x cubed. Then x squared terms. Minus 14x squared plus 3x squared turn up to minus 11. 14 minus 14 plus 3 is minus 11. Then minus 21x. There are no other similar x terms over here. So your final answer becomes 2x cubed minus 11x squared minus 21. Right. Then if you come up with this example, x times of 5x minus 3y into 2x minus y plus y. Initially, I just multiply with x with this bracket. X into 5x is 5x squared. X into minus 3y is minus 3xy. Then we can expand the brackets. 5x squared times of this entire bracket minus 3xy terms into this entire bracket. That's a way of simplifying this answer. First, you have to multiply this term with this, and this. Then this with this, this with this, and this with this. That is kind of familiar with this kind of simplification in our O levels. Then let's try to multiply. 5x squared into 2x is 5 into 2 is 10. X squared into x is x cubed. 5x squared into minus y is minus 5x squared y. 5x squared into 4 is 20x squared. Then minus 3xy into 2x. Minus 3 into 2 is minus 6. X into x is x squared y. Minus 3x squared into minus y is minus 3xy squared. Sorry, minus minus turn up to plus. This is a common mistake. It should be minus minus turn up to plus. Minus 3xy into plus 4 is minus 12xy. Then try to understand, are there any similar terms? X cubed terms, only this. X squared y terms, yeah, there are two. These two. Minus 5 minus 6 is minus 11 x squared y. X squared terms, only this. Then xy squared term, that is only this. And xy terms, only this. Then like that you can do this simplification, right? If you come up with part C, here initially you have to multiply these two brackets. X into x is x squared, x into 3 is 3x, minus 4 into x is minus 4x. Then you can simplify that 3x and minus 4x turn up to minus x. This is the just final simplification. Minus 4 into plus 3 is minus 12. Then multiply that one with x plus 1. When you multiply this expansion, initially multiply this x plus 1 with first term, then the second term and the third term. That is why they just, or we can just multiply like this, even doesn't matter. X squared into x is x cubed. X squared into 1 is x squared. Minus x into x is minus x squared. Minus x into 1 is minus x. Minus 12 into x is minus 12x. Minus 12 into 1 is minus 12. Then see whether are there any similar terms. X cubed terms only this. This plus x squared and minus x squared get cancelled. X terms are minus x minus 12x, that is minus 13x. Constant terms only minus 13 remain in this answer. Right. So this is just like the same, what do you call that, the simplification for this, that is just removing brackets, x plus 4 into x plus 7. So you just multiply x into x is x squared, x into 7 is 7x, 4 into x is 4x, 4 into 7 is 28. So you can simplify this 7x plus 4x and you can obtain the answer as 11x, and you can write the final answer as x squared plus 11x plus 28, right? Then if I come across with the part C, x minus 2 squared, that is a part C, if you refer, that is x minus 2 squared means x minus 2 into x minus 2. X into x is x squared, x into minus 2 is minus 2x, minus 2x into x is minus 2x, minus 2 into minus 2 is plus 4. Then these two terms again simplify and turn up to minus 4x. Then you can write x squared minus 4x plus 4, right? Okay. Then I will try to move up to question E. Right, here. X into 4x is 4x squared. X into minus y is minus xy. 3y into 4x is 3 into 4 is 12. X into y is xy, right? If you have some similar terms, just write in the same order. Then 3y into minus y, that is minus 3y squared. Now you can see these two terms are similar. 4x squared minus xy plus 12xy is minus 1 plus 12 is plus 11xy minus 3y squared, right? Then if you reach up to example H, 3x plus 2y squared is 3x plus 2y into 3x plus 2y, like this. Then 3x into 3x is 9x squared. 3x into 2y is 6xy. 2y into 3x is 6xy. 2y into 2y is 4y squared. Then you can operate these two. 6xy plus 6xy turn up to 12xy. Right. So that is the answer over here. Then you can write 9x squared plus 12xy plus 4y squared is the final answer. Right. Then if you come across this kind of question, these simplifications are you a little bit familiar, but just try to understand how to do this, right? Then you can say this is 2x into 2x is 4x squared. 2x into 3 is 6x. 8y into 2x is 16xy and 8y into 3 is 24y. Now see with the other similar terms. X squared terms only 1, x terms only 1, xy terms only 1 and y terms only 1. Therefore, that is the final answer for this question, right? Okay. Then, if you come up with question number J, x plus 5 into 2x plus 3y minus 5. X into 2x is, you can say 2x squared. X into 3y is 3xy. X into minus 5 is minus 5x. Then 5 into 2x is 10x. 5 into 3y is 15y. 5 into minus 5 is minus 20y, 25. Then see whether are there any similar terms. X squared terms only 1. Xy terms only 1. X terms only 1. And yeah, x terms only. So see whether are there any other similar x terms. Yeah, there are 2. Here you can see 5 minus 5x and plus 10x turn up to plus 5x. Y terms only 1 and constant terms only 1. Like that, you can use the same technique to obtain the answers in this exercise, right? This one also, what we need to do is we have to use the same technique. If you come across the first example, initially multiply 5 with x is 5x, 5 into 1 is 5, then multiply these two brackets. 5x into x is 5x squared, 5 into minus 4 is minus 20x. 5 into x is 5x. 5 into minus 4 is minus 20. Then 5x squared, you can operate minus 20x and plus 5x at once. Minus 20 plus 5 is minus 15x. Minus 20 comes over here. You have to work out all the examples with the similar technique here. I have worked out all of these sections, so you can practice these questions using these examples. Hopefully, you'll be able to handle these questions. Right? These are all the answers are over here, so you can just go through them and see whether can you manage with these questions. I have mentioned all the steps with the relative all the steps almost, but if you are familiar enough, no need of writing all the steps, and you can obtain the final answer. I have worked out all the steps to give you a clear answer how to do this simplification, right? If you come across this kind of a word problem, the diagram shows a rectangle square cutout. A rectangle has a length of 3x minus 5 plus 4 and width x plus 1. The square has a side of x minus 2. If this side is x minus 2, this length also x minus 2. Find an expression of the simplify for the shaded area. If you want to get the shaded area, what you need to do is you have to obtain the total area minus this area of the square. So if you have to get the area of this rectangle and subtract the area of the square, area of the rectangle become 3x minus y plus 4 into x plus 7. The square is x minus 2 each. Therefore, you can multiply 3x minus y plus 4 by x plus 7. You have to subtract x minus 2 squared out of that. Let's see how to do this simplification. Right? Then, if you just multiply with x into 3x is 3x squared. X into minus y is minus xy. X into plus 4 is plus 4x. Then 7 into 3x is 21x. 7 into minus y is minus 7y. 7 into 4 is 28. Minus, then you have to expand this bracket to them. X minus 2 into x minus 2 is x into x is x squared. X into minus 2 is minus 2 minus 2x, with this minus turn out to plus 2x. Then minus 2x into x is minus 2x. If you multiply again with this minus, it's plus 2x. Minus 2 into minus 2 is plus 4. Again multiply with this minus is minus 4. Then see whether what are the similar terms. 3x squared and x squared. 3x squared minus x squared is 2x squared. Minus xy, there is no other xy term. So you can just write minus xy over here. Right? Then x terms. 4x, again 2x and 2x. Is there any other term? Yeah, there are 4 terms. 4x plus 21x is 25x. 25x plus 4x is 29x. Y terms. There is only one y term minus 7y, and the constant terms are over here 28 minus 4 turn up to 24. That is the final answer for this expression. Right. The next important point is to learn about the negative and the fractional indices. So I have already mentioned this one at the beginning of this term even. So if you get a to the power 1 over m, you can write that is the mth root of a. We will work out these questions a little bit later. For example, if you get a to the power half, that is the square root of a. If you get a to the power 1 over 3 is a cubic root of a. Then if you get a negative power, you can write it as a reciprocal and you can write it, and the 0 powers you can write it as 1. So this operation I will show you in an example how do we have to operate these ones, right? Okay. Then for example, if you want to get x to the power 3 divided by x to the power minus 3. So this is division is a subtraction. So you can write this is x to the power 3 minus minus 3, that is x to the power 6. Then the next operation is x to the power half into x to the power 3 over 2. When you multiply, you can add the powers. That is half plus 3 over 2 is 4 over 2, that is x to the power 2. 4 over 2 is 2, x to the power 2, right? Then the power of power theory. X to the power 3 to the power 2 over 3. Then you can multiply the powers. 3 into 2 over 3 is 2. That is answer is x to the power 2, right? Then the next example is 2 times of x to the power 1.5 divided by 4 times of x to the power minus 0.25. 2 divided by 4 is half, 0.5. Here this when you operate the powers, x to the power 1.5 minus minus 0.25. This division is this minus and this minus 0.25 come over here. So your final answer is half x to the power 1.5 minus 0.25 is 1.75. So your final answer turn up to half x to the power 1.75, right? Okay. The next example is, this is the point you have to understand. This is the cubic root, means power 1 over 3. That means 125 x to the power 6 to the cubic root means 125 x to the power 6 to the power 1 over 3. So this operation is 125 to the power 1 over 3. You can use your calculator and replace this value 125 to the power 1 over 3. You will obtain the answer as 5. Then x to the power 6 to the power 1 over 3. So if you have a power for this, you have to operate the both terms with the same power. 125 to the power 1 over 3 into x to the power 6 to the power 1 over 3, right? Here, 125 to the power 1 over 3 is equals to 5. X to the power 6 to the power 1 over 3 is power of power theory. You can multiply these powers and you can write x to the power 6 into 1 over 3 is 2. With that, you can obtain the answer 5x squared, right? Then if you operate this example, as I mentioned the previous example, if the division is just a single term, you can divide these two terms separately. 2x squared divided by x to the power 5. Then minus x divided by x to the power 5. 2x squared divided by x to the power 5 is 2. You can subtract the powers, x to the power minus 3. X divided by x to the power 5 is 1 minus 5. That is x to the power minus 4. This negative power you can write in the denominator and you can write 2x to the power 3 minus x to the power minus 4, you can brought it down. That is turn up to, if you brought this x to the power 4 down, the number here is 1. So that answer turn up to 1 over x to the power 4. That is the most important point where we have to understand. Or you can use the negative power as 1 over the positive integer power, what we have learned in our previous theories. Then these are the numeric simplification. 9 to the power half means this is square root of 9, that is 3. If you want to get 63 to the power 64 to the power 1 over 3, that is a cubic root of 64. Cubic root of 64. That is, you can put the calculator and you can obtain this answer as, this is 64 is 4 to the power 3. Therefore, the cubic root turn up to 4. This is the operation where we have to understand. 49 to the power 3 over 2. We know we can say this one. If you had such question, it's just like this. So here the answer is 49 to the power 3 over 2 is a problem. If you have such fraction, you can use this fraction and you can write the answer this way. 49 to the power half. You can write this answer as, you can use the denominator and write it as 1 over 2. Then you can put the power at top as a power. So that is a simple answer. It's a reciprocal of it's opposite operation of the power of power theory. So you can say this denominator power, write it over here as 1 over 3 and the top power, write it over here. Then we know that 7 to the power 1 over 2 is square root of 49. Square root of 49 is how much, children? 7. 7 to the power 3. That is why this 7 to the power 3 came over here. With that you can operate. 7 to the power 3 is 343. That is the final answer for that question. Then if you happen to find 25 to the power minus 3 over 2, initially what you need to do? Initially you have to make them into positive power by breaking it down. Then that is 1 over 25 to the power 3 over 2. So how do you get this 25 to the power 3 over 2, children? 25 to the power 3 over 2, you can write 25 to the power, division is 2, so you can write it's 1 over 2. Then write the total, what you call numerator power as the outside. 25 to the power 1 over 2. It is how much, children? 25 to the power 1 over 2 is the square root of 25. Square root of 25 is how much? It's 5. So it's turned out to 5 to the power 3. So this is 5 to the power 3. 5 to the power 3 is 125. Therefore, 1 over 5 to the power 3 becomes 1 over 125. That is the final answer for this question, right? Okay. Then, if you operate these other examples, exercise where we have to try out You can try these questions and see whether can you obtain these answers. If you come up with this question, that is x to the power 3 divided by x to the power minus 2 is at the division, you can subtract the powers. That is x to the power 3 minus minus 2. That is 3 to the power 3, x to the power 3 plus 2, minus minus 2, not to plus 2. So x to the power 5, right? Then over here the same thing. When you work out this question, you can see you can add the powers. 3 over 2 plus 5 over 2 is 8 over 2, that is 4. This is a power of power theory. You can multiply the powers. 2 into 3 over 2 is to the power 3, right? That is how you need to work out. Right, if you happen to work out over here, you can say 3 into 4 is 12. X to the power 0.5 into x to the power minus 0.5 is you can add the powers. Plus 0.5 plus minus 0.5 is 0. We know that any term to the power 0 is 1. So your final answer turn up into 12 into x to the power 0 is 1. 12 into 1 is 12. Like that you can operate here also. You can just 9 divided by 3 is 3. X to the power 2 over 3 divided by x to the power 1 over 6 is your subtract. 2 over 3 minus 1 over 6 is 1 over 2. So the final answer is 3x to the power 1 over 2. Similarly, you can operate all of these questions if you come across with this. Here, square root is power half. Cubic root is power 1 over 3. So you can add the powers because the operation here is multiplication. If you add them, you can write the answer x to the power 5 over 6. Or you can write x to the power, the 6th root of x to the power 5. But this operation is kind of exceptional. You can write the answer in this format, right? Then this answer. How do you operate this? X to the power square root is power half. Half to the power 3. So you can use the power of power theory. Square root x is half. X to the power half to the power 3. Half into 3 is 3 over 2. Cubic root means x to the power 1 over 3 here. To the power 4. That is 1 over 3 into 4 is 4 over 3. Then you can add the powers. 2 over 3 plus 4 over 3 turn up to 7 over 6. So you can write this is x to the power 17 over 6. So these operations also, same thing you can operate. 25 to the power half is square root of 25, that is 5. Then if you operate 81 to the power 3 over 2, that is if you use the same technique what we have used, that is 81 to the power 2 over 3 means this is 81 to the power, you can write this is denominator 2, you can write 1 over 2 to the power 3. You know that 81 to the power half is square root of 81, that is 9 to the power 3. 9 to the power 3 is turned up to 729. That is how you can obtain this answer, right? Here this is 71 to the power 1 over 3 is cubic root of 71, that is 3. So you can use the calculator and you can obtain the answer. Here if you gain a negative power, you can write 1 over that number 4 to the power 2, that is 1 over 16. Here also the same thing. 9 to the power minus half is 1 over 9 to the power half, that is 9 to the power half is square root of 3. Answer is 1 over 3, right? Here this is another very good theory. If the power is 0, whether it's a fraction or a negative value or an algebraic term, whatever, the final answer becomes 1, right? Then if you work over here, how do you express this answer? Here you can say this is 1296. The denominator power is, you can write it as 1 over 4. 1 over 4 to the power 3. You can write the denominator power as 1 over 4 and 3. So this answer is 6. This is 6 to the power 3 is the final answer. Then you can obtain the final answer as 216. If I repeat it, 1296 to the power 3 over 4, you can write denominator power is 4. You can write 1 over 4 to the power the numerator power. Then 1296 to the power 1 over 4 is 6. 6 to the power 3 is the answer, that is 216, right? That is how you need to get these answers for the first part of the topic. Again, we will meet the second part of the topic, that is third, in next videos.